All right, so which of the substances shown in this problem will react significantly with sodium bicarbonate? Okay, so how do we figure this out? Sodium bicarbonate is the base. It's the sodium salt of carbonic acid, which has a pKa of 6.37. So the question is, you have Na, that's the spectator ion, HCO3 minus. That's the sodium salt of carbonic acid. So this is the conjugate base of carbonic acid, which is H2CO3, carbonic acid, and the pKa of this is 6.37. So the question is, if we add this as the conjugate base, the base, to any one of these in 2.40, will we get a significant reaction? So does the equilibrium lie to the left or to the right? And then the conjugate base of this compound would be plus X, some conjugate base. So this is the conjugate base of the compound in 2.40. Okay, so we really don't need to know the structure. All we need to know is the pKa, right? Because some compound, let's just call it compound Y here. Compound Y is the acid. If sodium bicarbonate, so this is bicarbonate. Sodium bicarbonate is the base, then Y is the acid. Oops. And the question is, which one of these, if any, will react with sodium bicarbonate to drive this equilibrium to the right? So in order for this reaction to take place, to say that a reaction has taken place, we really want to say that the equilibrium lies to the right and not to the left, because as we saw in the previous problem, if the equilibrium lies far to the left, we simply say that it's really not reacting or not reacting much. And so remember that the equilibrium lies toward the weaker acid. And the weaker acid, remember, has the higher pKa. So that's really all you need to know. And which one of these has a higher pKa than carbonic acid? Well, all of them except acetic acid. So 19.3, 9, 9.9, those are all higher. So if we look at acetic acid, that's the only one that's lower. So if we put in acetic acid here, and I'll put this in a different color, acetic acid, CH3COOH. This is acetic acid. That's the acid in this equation. The pKa is 4.76. And we'll just go ahead and write out its conjugate base. So the conjugate base of acetic acid is CH3COO minus. And I'll put in the lone pairs here. So the weaker acid has the higher pKa. This is the weaker acid. It's 6.37 versus 4.76, and the equilibrium lies toward the weaker acid, which in this case means that we have a forward reaction. The forward reaction is greater than the reverse reaction, therefore you will see, if you add sodium bicarbonate to acetic acid, you will see a reaction, and actually generally what happens is you have the formation of carbonic acid, which loses CO2, and CO2 and carbonic acid make, and the loss of CO2 corresponds to the production of a molecule of water, and when I say minus CO2, CO2 bubbles, and this is why you get, since CO2 is a gas, you get bubbles when you add sodium bicarbonate to an acid.